4A is just going to be a little introduction to probability and a review of some concepts that you have studied in previous math concepts. Okay, so as an example for all of these, we're going to look at rolling a regular six-sided die. So it has numbers from 1 through 6. The sample space is all of the possible outcomes. So the things that can happen when I roll this die. I can get a 1, a 2, a 3, a 4, a 5, or a 6. That is my sample space. Okay? An event would be just a subset of that sample space. So if I can find the probability of an event, I want to know the probability of rolling an even number, the probability of rolling a 4. Okay, that is an event. And then the outcome is what actually happens. So I rolled it and I got a 2. That was my outcome. All right, there are two kinds of probability that we're going to talk about: theoretical probability and experimental probability. So theoretical probability is just a mathematical calculation. So number of favorable outcomes over number of possible outcomes. So if I asked you for the probability of rolling a 2, well, there's 1, 2 on that die, and there are 6 different numbers, or 6 possibilities. So my probability of getting a 2 would be 1 out of 6. If we're talking about experimental probability, that's where we are actually going to roll the die. So I'm going to roll that die 100 times. Okay, so 100 times I rolled it, and we'll say 17 times I got a 2 when I rolled it. Okay, that would be my experimental probability, 17 out of 100. Okay, now that is not equivalent to 1 over 6, but that is okay. In terms of rolling that die, 100 is sort of a small sample size. So we have something called the law of large numbers. And what that says is the more times I repeat an experiment, my experimental probability is going to get closer and closer to my theoretical probability. So if I roll it 100 times, it might be sort of far away from 1 over 6. But if I rolled it 1,000 or 1,000,000 or 1,000,000,000 times, the more I do something, it's going to get closer and closer to that theoretical probability. Some basic rules of probability that you need to make sure you understand. The probability of any event is between 0 and 1. 0 meaning it is completely impossible, and 1 meaning it is absolutely certain that it is going to happen. All right, so you cannot have a probability less than 0, and you cannot have one that is greater than 1. All the possible outcomes together must have a probability of 1. So if I look at that die again, the probability of me rolling an even number, well, that would be a 1, a 3, or a 5. So that is 3 out of 6. The probability of me rolling an even number, a 2, a 4, or a 6, would also be 3 out of 6. 3 out of 6 plus 3 out of 6 is 6 out of 6, or 1. Okay, all of the possible things that could happen when I roll that die, if I have the probability of all of them, they have to add up to 1. All right, and then the probability that an event does not occur, that's also called its complement, is 1 minus the probability that it does occur. So the probability of me rolling a 2 would be 1 out of 6. The probability of me not rolling a 2 would be 1 minus 1 out of 6, or 5 out of 6. All right, and then finding the sample space. So 3 different ways that we can use to find the sample space. One is just count the outcome. So if I have something simple like a die or a coin, I can look at that coin and say there's 2 sides, there's a head and a tail. Those are my 2 outcomes. All right, so my sample space would be heads or tails. We can make tree diagrams. Okay, so you've seen these before. So here's an example of a tree diagram. All right, at snack time, the preschool students can choose from white or chocolate milk and chocolate chip or oatmeal cookies. So here are their choices: white milk and chocolate chip cookies, white milk and oatmeal cookies, chocolate milk and chocolate chip cookies, chocolate milk and oatmeal cookies. And this would be my sample space, these 4 things. Those are the 4 different choices that they could come up with combining these things. Okay, sometimes tree diagrams can get really complicated the more choices that we have. So let's say that I added in here the white milk could be 1% or 2%. And same for the chocolate milk, 1% or 2%. And I could also throw in like an almond milk. Okay, and then not just chocolate chip and oatmeal cookies, let's throw in some peanut butter cookies and some Oreos. All right, now I would have to add trees for all of these things, which would mean a very big tree diagram that would be kind of annoying to draw. So that's where our third method comes into play, the fundamental counting principle. All right, and the fundamental counting principle just says if I have a certain number of choices for one event and then a certain number of choices for a second event, then I can multiply those two numbers together to get the total number of outcomes. So if I go back to all of the additions that I made to our preschool snack here, we have now 1, 2, 3, 4, 5 different options for milk, and 1, 2, 3, 4 different options for cookies. So if I use the fundamental counting principle, I would say there are 5 outcomes for milk times 4 outcomes for cookies, which means there are 20 different outcomes, 20 different ways that you could combine those milk and cookies to come up with the options. Okay, and that's it for day 1.